So now that we've talked about how to implement the search with sequential loops approach, the sequential loops approach to looking for elements, let's go ahead and take a look at how to do the same logic sequentially using streams. So this is going to be a search with sequential streams implementation strategy as opposed to the search with sequential loop strategy. And this will also help to see the transition from loops and object-oriented features and if statements and so on into the world of streams. So hopefully it'll serve as a Rosetta Stone to make it easier to do your assignments. So in this case, as before, we have a class called SearchWithSequentialStreams, which extends SearchStreamGang, which means it has to override the hook method, processStream. Here's the constructor that calls up to the superclass and gives the phrases to find and the strings to search. That's identical to what we did before. Here then is the processStream method. Now this actually uses a stream, unlike the previous example, which somewhat confusingly used a loop, but was called processStream. So it starts out the same. We're going to get the input as a list of character sequences. So this is the complete works of Shakespeare as a list of character sequences. But now things diverge quite a bit. So instead of any loops, instead of any if statements, instead of having to allocate anything explicitly, we use streams to do all that for us. So the first thing we do is we say, input list, convert yourself into a stream, please. And if you were to take a look at the .stream method, of course, under the hood, stream is going to basically end up calling stream support.stream using the splitterator for that particular data type, in this case, array list, and passing in the flag false. So that's basically just saying, make me a stream. So now we have a stream of character sequences corresponding to the works of Shakespeare. We're then going to use the map operation. And so map in this case is basically playing the role of the body of the loop that we had in the object-oriented version we just looked at. So in this case, we're going to pass in a method reference to map, which will be the behavior that we want map to be performing for each element in the stream. And in that case, it'll be the processInput method. We'll look at that in a second. processInput returns a list of search results. So map will return a stream of lists of search results, one for every element returned from processInput, because of course, remember, map always has to have the same number of elements coming out of the stream as went in to the call to map. And then the final thing we're going to do here is we're going to use the collect terminal operation to turn the stream of lists of search results into a list of lists of search results. And that's exactly what gets returned from processStream. We have a list of search results, which is then flattened by flat map in the print phrases method, which we've talked about before, and we'll look at in more detail later. Down here is processInput. You can kind of think of processInput as kind of like the equivalent to a subroutine that's being called by processStream. And what happens here is it goes ahead and it gets the title, which we saw before. It extracts the title of the work from the input sequence. We then use subsequence to skip over the title and then get the rest of the work of Shakespeare in a character sequence we call input. I probably should have called it work because it's a work of Shakespeare. And then down here, once again, we use a stream instead of using a loop. So we're going to say phrases to find .stream. So now each phrase we're looking for will be turned into a stream of phrases. And then for each phrase in that stream of phrases, we're going to use the map intermediate operation to go search for that phrase in the input work. Now, we saw search for phrase before in the context of the object-oriented version, which had a bunch of loops in it and if statements and so on. Now let's go ahead and take a look at search for phrase that we use here. And this method appears in the SearchStreamGang superclass. And the reason it occurs here is because it's reused by all the other strategies, or most of the other strategies. So here's search for phrase. It takes a phrase, it takes an input work, it takes the title, and a flag to indicate whether we want to search in parallel or not. Right now, we're going to be searching sequentially, but when we do the parallel Splitterator version, we'll be searching in parallel. And what we do then is we say stream support.stream, which is a helper method that comes as part of the Java Streams framework. And we pass in a splitterator. And that splitterator, of course, is going to be the phrase match splitterator that we've talked about before. And the phrase match splitterator is going to take the input work and the phrase, and in this case, it'll create a sequential stream because parallel flag is false. It'll create a sequential stream of all the places where that phrase occurred in the input. So if we look at phrase match Splitterator, here's the phrase match Splitterator. You can see it's a helper class that implements the Splitterator interface, customizing it with the result object, which keeps track of the index where a phrase occurred in the string. And we've got a bunch of fields. We've got the input string. We've got the phrase we're searching for. We've got the pattern matcher, and so on. And those things are set in the constructor of phrase match Splitterator, which does a very similar set of tricks with regular expressions that we looked at earlier. And so that part's all pretty much the same. The main thing I want to show you here, just quickly, because we've looked at this earlier, is the try advance method. So remember, for this particular implementation, we're only doing sequential searches. We're not doing parallel Splitterator searches. So all that matters is the try advance method. Here's the try advance method. It's passed in a consumer action, customized for the result type. And if the phrase match find method returns false, that means nothing else to find here. There's no more matches in the string, in which case we return. Otherwise, we found a match, and then we go figure out where the match occurred, and we create a result object that keeps track of that index location. We accept that into the action, which is a consumer, and that allows us to pass that information back to the streams framework, which will then use that in order to make us a stream of these result objects. And we return true, saying, hey, streams framework, keep going. There could be more. We got a hit. There could be more hits. Okay, so that's basically what's happening here. And so we're taking that stream, turning it into a list. So we have a list of search results.result objects. Now notice that this is entirely functional. There's no looping. There's no if statements. It's all just done in a very clean, functional way with no side effects. It's all pure functions and pure stateless Lambda expressions and so on. And then the result is we make a search results object with that results list tucked into it. So that's what the search for phrase method does. As you can see here, what we really have done here is take the original logic that we'd used for the version that was based on the for each loop and object-oriented programming, and just kind of refactored it to get rid of the control constructs, the loops, the if statements, and so on, and just left the computations to be glued together in a fluent way by the internal iteration of the streams mechanisms. So that's really the key essence here. And of course, this is very similar to what you're doing for your programming assignment 2A, where you're taking the loops version of the sequential loops crawler and converting it to a sequential streams crawler. Much the same idea. You don't loop, instead you convert the collections into streams, and then you basically put a pipeline of different intermediate and terminal operations together in order to do the transformations and or filtering required to process those things as you need to. So hopefully this will help you kind of see the congruence between an object-oriented approach in the more classic sense and a functional streams approach in a more modern sense of Java. And you can kind of use this as a Rosetta Stone to make sense of how to do the things you need to do for your program. Now, we won't go over this right now because we're running short of time, but the next thing we'll look at will be the parallel streams version of this. And just to give you a little spoiler alert, because it's super easy, the only difference between the sequential streams version and the parallel streams version is everywhere you see the word stream, like here and like here, that'll go to parallel stream. And that's all there is to it for the simple way of converting a sequential stream to a parallel stream. And as it turns out, even though that's ridiculously simple, you can see the speed up we get from the sequential version to the parallel version, basically getting a 6+ fold speed up without doing really anything to our code. And that is why the functional approach is so powerful. That's why streams is so powerful. That, of course, is why we don't want to get ourselves basically stuck in the Procrustean bed of the accumulator anti-pattern. And the accumulator anti-pattern, of course, would be this code. So this code here where we have the explicit loops, this kind of code right here, that's the accumulator anti-pattern. Because to change this code to run in parallel is going to take a lot of work. Conversely, to change this code to parallel takes almost no work. It takes a minuscule amount of work. So that's the key essence I want you to remember when we look at this stuff. And hopefully you'll have a better time doing the other assignments because you'll see how easy it is to switch back and forth between sequential and parallel using a nice functional framework like Java Streams.